Today's video is on order of operations. You'll want to make sure that you have your order of operations guided notes out in front of you. Feel free to pause the video throughout so that you can copy down the guided notes on your paper. Okay, this unit we will not be using calculators. If you want to check your answers using calculators, fine, but when you're taking quizzes, tests, and doing classwork assignments, you will not be able to use your calculators. There will be future units where we will, but because our goal is to really be able to compute with numbers, we're not going to be using our calculators at all. So again, you want to have those order of operations guided notes out in front of you. An order of operations is probably something that's fairly familiar to you. You've seen it before. You might see some more challenging problems here, which we'll get to towards the end of the guided notes. So numerical expressions contain a combination of numbers and operations such as addition, subtraction, multiplication, and division. You've worked a lot with numerical expressions, and they're used a lot in the real world as well. You're going to be asked in the directions to evaluate. It's not going to say solve, which is what you typically hear. It's going to say to evaluate your expression. And to evaluate an expression means to find its numerical value. And again, you think of this as solving, but technically if you're solving for an unknown. What we're trying to find here is the answer to a problem, and so we're evaluating that numerical expression. Now, the order of operations you might have learned in a lot of different ways, maybe PEMDAS, please excuse my dear Aunt Sally, you might have heard. But what I did was I listed out the different order of operations here from left to right. The first is grouping symbols. I don't just say parentheses because we're looking at lots of different grouping symbols here. This is where you might want to copy this stuff down into your guided notes. We do have parentheses, of course, right here. We also have the brackets, which we often use if we have multiple sets of parentheses, but we treat them exactly the same. And then the last one are these double bars going down, which are absolute value bars. We'll talk a little bit more about them. You've probably seen them in previous years as well. The second thing is exponents. We'll talk about exponents in this lesson also, so we'll just mix that right in. And again, probably something you've seen before. Now, multiplication and division, I put hand in hand. I think the tricky thing about PEMDAS is people assume that multiplication has to come before division, but it does not. For multiplication and division, if that's what you have in your problem, if you have both operations, you're going to do whichever operation comes first from left to right. So you work left to right. Okay, same goes with addition and subtraction. Make sure you do all multiplication and division first and then move on to your addition and subtraction. And again, if your problem is, let's say, 10 minus 3 plus 8, you're going to work left to right there. You're going to do that subtraction first. You're going to work left to right. Those are important things for us. And again, that's the order of operations. Those are things you've seen before. All right, so the first thing I want to review or talk a little bit about is exponents. So if we have this 3 to the 4th power, that's the way we say that. 3 to the 4th power, the big number is what we call our base, big number base. That's the number that's going to be repeated, the number that's going to be multiplied. The little number is our exponent, and that tells us how many times the base is used as a factor, how many times we're going to multiply it. The entire thing together we call the power. Sometimes I'll accidentally call it an exponent when really the exponent is just the little number. It's important to be precise with our language. I try to do that as much as possible when I'm teaching, but sometimes, we say things not exactly correct. Something that might be new to you though, I think you've seen exponents before, is that any number raised to the 0 power is equal to something. And oftentimes in class, I'll ask students to make guesses what they think it is. They'll tell me 0, they'll tell me the number, but it's not. Anything with a 0 power is actually equal to, it's supposed to be back here, it's not. We'll type it in real quick, no big deal, is equal to the number 1. So any number raised to the 0 power is equal to 1. So if I have 5 to the 0 power, that's 1. 8 to the 0 power, that's 1. Negative 15 to the 0 power, that's 1. Anything to the 0 power is equal to 1. This is something that's addressed a lot during algebra. I often have students who ask why. If you're really interested, Google it. You should be able to figure out by Googling it why any number raised to the 0 power is equal to 1. It's quite interesting, actually. This double star down here, a lot of times I'll put stars next to things that are really important. You must put parentheses around the base whenever the base is a negative number. So if your base is a negative number, you need to make sure to put that in parentheses. If the base is a fraction, you'll also put it in parentheses. And also when the base is an expression, which we'll see. Again, some of these things might be a little new for you. A lot of times when we get to 7th grade, we just bump up the difficulty level of some of the things you've seen in the past. So let's go into some exercises, and you can feel free to try some of these on your own. Pause the video and then check them afterwards, but please make sure you're checking. Don't just listen to the video and complete the problems and do them wrong and not go back and fix them. It's really important that you, if you make any mistakes, you double check your answers. So number 1, I've got 5 times 5 times 5 times 5 times 5 times 5 times 5. That's going to be a base of 5, and it's going to be 5 to the 7th power since I have 7 5s being multiplied. So we just add those up, figure out how many we have. We have 7, so it's 5 to the 7th power. Number 2, we've got negative 7 times negative 7 times negative 7 times negative 7. You're going to notice I use parentheses to represent multiplication there without a dot in between or a times sign in between. It doesn't matter. We don't have to put them if we put the parentheses there. Now, you need the parentheses, but we have 4 negative 7s being multiplied. So it'll be negative 7 in parentheses to the 4th power. No parentheses, it is wrong. Okay. Number 3, our base is a fraction this time. We have 1/3 times 1/3 times 1/3. That is 1/3 to the 3rd power since we have 3 of them being multiplied. Again, our base is a fraction, so we put that in parentheses. Number 4, let's throw in some variables. D times D times D times D times D. That's going to be D to the 5th power. We have 5 D's being multiplied. Number 5, we have 2 A's, 4 B's, 2 C's. So we put this as one expression. A to the 2nd power times B to the 4th power times C to the 2nd power. I will mention you don't need to have the dot that's between each of these. You could just have A squared, B to the 4th, C squared. Instead of saying to the 2nd power, we sometimes say squared. My son actually, he's been watching this show called Number Blocks, and they do a lot of square numbers. So they'll do 5 squared, 6 squared, which is the same as like 5 times 5 and 6 times 6. Number 6, we have numbers and variables mixed together here. We have 2 negative 3's, 3 D's. So we have negative 3 to the 2nd power times D to the 3rd power, or D cubed. You'll notice that I didn't put a time sign or a dot between these. I don't need it, but I can have it. What I do need, though, are the parentheses around the negative 3, our base, since it's negative. Number 7 and 8, this is where I mix in some expressions. And again, I often have students, if we're in class, try these. They'll actually put their answers up on the board. And a lot of times students are correct, which is fantastic. Students in the last couple of years have done a really nice job with these. So if I have x minus 2 times x minus 2, that is x minus 2 in parentheses to the 2nd power. You need the parentheses there. It's not x to the 2nd minus 2 to the 2nd. If you take algebra, you will learn what that's equal to, but it's not x to the 2nd minus 2 to the 2nd power. So if we want to write it using exponents, there we go. Number 8, we have 4t plus 4's, so we have t plus 4 to the 4th power. The number that's inside isn't always going to match the exponent. It just happened to for these 2 examples. All right, pause the video. I want you to give these 4 independent practice problems a try, even if you just think about them or if you choose to write them down. All right, hopefully you've answered these 4. So number 1, hopefully you got 6 to the 4th power. Number 2, we've got 1, 2, 3, 4, 5, 6 negative 5s. So negative 5, you must have the parentheses to the 6th power. Number 3, 3 B's, 2 W's, B to the 3rd times W to the 2nd, or B cubed, W squared. You don't need the dot between them, although you can include it. You'll notice here we generally use the dot for multiplication instead of an x because we use the variable x quite a bit. Finally, number 4, this is going to be u minus 8 cubed, or to the third power. Hopefully you did pretty well with those. Students in the past have done pretty well with this. All right, now we're going to evaluate each of these expressions, which means get a number answer for these. So 6 to the second power, we know is 6 times 6, which of course is 36. So my answer is 36. 3 cubed is 3 by 3 by 3, or 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So final answer is 27. And again, if you need to pause the video because you need to get caught up with writing anything, or you need to pause the video because you want to try them on your own, feel free to do that. 7 squared is 7 times 7. Remember, not 7 times 2, but 7 times 7. That's 49. Hopefully you know these off the top of your head. So that'll be our final solution. Now last year I had some negative numbers mixed in, but we don't talk about those until a little later in the unit. So I threw in some fractions this year. I changed these. So 1/2 squared is 1/2 times 1/2. Oops, I shouldn't have uncovered that yet. We just multiply straight across. So 1 by 1 is 1, 2 by 2 is 4. Our answer will be 1/4. Essentially, you're taking 1 to the second and 2 to the second and putting them together in a fraction. All right, 1/3 cubed. So that is 1/3 times 1/3 times 1/3. 1 by 1 by 1 is 1. 3 times 3 times 3, we saw up here, that's 27. So hopefully you recognize our answer is 1/27. Those were a little tricky, but I do like to mix fractions in as well since we do see them pretty frequently in real life. All right, so let's do some order of operations questions. And I know this video gets kind of lengthy. I really want you to make sure that you're showing your work for these problems just like how I'm doing it. You're going to notice that I work down. I often see students putting little numbers hovering above things. We're going to get some really complicated problems as we get towards the end. So I would suggest working down as you do the problem. I have found, and this is like year 16 or 17 now, I've lost track, I think it might be 17. We've, I, just from my experience, I know that working down benefits students a lot more than just working straight across or putting their work all over the place. So I would really recommend you copy the work down exactly as shown in the notes. So number 14 is done for you. I've got 6 plus 3 times 9. Start off going through parentheses or grouping symbols, don't have any. Exponents, don't have any. Multiplication and division, well, it looks like we have multiplication here, so let's start with that. Sometimes students underline it, sometimes they highlight it, sometimes they make like a little V going down is fine. Sometimes students do nothing, that's okay. I underlined it, so we do 3 by 9 or 3 times 9 first to get 27. Then we just do 6 plus 27. We replace 27 with, we replace this with 27, I should say. 6 plus 27 is 33. I do always like to circle or box in my answer. I think that's kind of important to do, once I get my final solution, so I know this is my answer. Number 15, we have 7 plus 7 times 3. So start off by doing multiplication, just like the last problem. So I'm going to do the 7 times 3 first. I'm going to underline it as we go. So I'm going to do this part first. 7 times 3 is 21. So now I get 7 plus 21. I don't really need to underline that since it's the last step that I'm going to do, but I'm going to do 7 plus 21 next, which of course is a solution of 28. It's really easy to make calculation mistakes here. And if you do, it's not the end of the world. You just fix it. We all make those mistakes, myself included. I will make plenty of them this year. It happens. Number 16, we have 10 divided by 5 times 3. So I'm going to start off in this problem. I notice that I have multiplication and division, no parentheses or grouping symbols, no exponents. And I'm going to remember that for multiplication and division, I work from left to right. So I'm going to do 10 divided by 5 first instead of doing 5 by 3 or 5 times 3 first. 10 divided by 5, be careful, it's not 5, it's 2. And then I just need to do 2 times 3 to get my final solution. If you saw, I showed the answer by accident. 2 times 3 is going to get us 6 for our solution. Again, we just work through that step by step. Number 17, let's go ahead and take a look at this one. We have 2 and then in parentheses 6 plus 2, our first grouping symbols, minus 4 times 3. So let's start off by working inside those grouping symbols. So I'm going to do 6 plus 2 first. 6 plus 2 is 8. Now you're going to notice I dropped the parentheses at that point. And I also know that if I have a number right against a set of parentheses, that means to multiply. So I'm going to replace this set of parentheses with a multiplication sign. You may keep the parentheses if you choose. At this point, I'm going to do 2 steps in one. I've got 2 sets of multiplication, 2 by 8, 4 by 3. 2 times 8 is 16, 4 times 3 is 12. Obviously, I'm going to finish by doing 16 minus 12 to get a solution of 4. So nothing too bad. We just mixed in some grouping symbols. Go ahead and pause the video. Give number 18 a try. All right, hopefully you paused the video and you tried number 18 on your own because it's literally identical to number 17, just with different numbers. So for this one, I'm going to start off by doing 6 plus 1 to get 7. I'm going to take 5 times 7, which is 35. 3 times 3 is 9. And 35 minus 9 is 26. Number 19, this one we have brackets and parentheses. So we work from the center out. So for this problem, I'm going to start with the parentheses that are inside the brackets. So I'm actually going to begin with the 13 minus 4 and do that first. 13 minus 4 is 9. Inside the brackets, I do have parentheses, and those actually represent multiplication here. A lot of times I'll replace that with 2 times 2 instead of leaving the parentheses there because I need to do multiplication before I do addition. It's really tempting to do the 9 plus 2 first, but for this problem instead, I want to do 2 times 2 to get 4 next. We still follow order of operations even inside our grouping symbols. So now I have 9 plus 4 from the 2 times 2. And again, if you want to drop those parentheses and replace it with a multiplication sign up here, feel free to do that. So next thing I'm going to do is 9 plus 4. That's going to get us 13. So I have 2 and then the brackets 13, which you can replace with a multiplication sign. So I'm going to do 2 times 13 to get my final solution, and that's going to get us 26. Again, you can always drop off. Once we've done everything, don't drop off those brackets until we've done every operation inside them. So notice how I didn't drop them off up here or here. I waited until I had one answer, no operations left. I can drop them off then if I want and just write this as 2 times 13. All right, number 20, try this one on your own because it is exactly like number 19, except we have different numbers. So go ahead and give that one a try. Pause the video. All right, hopefully you pause the video. We're going to start off by doing 10 minus 6, which is 4. Again, if you want to replace the 6 parentheses 2 with 6 times 2, you can. So don't forget, we need to do 6 times 2 before we add the 4. Order of operations, we always follow them. 6 times 2 is 12. 4 plus 12 is 16. 16 times 4 is 64. Again, you can replace the brackets here with a multiplication sign if you choose. You do have a little bit of leeway. Even in math sometimes, you just want to make sure you know what those parentheses and brackets represent in the problem. All right, number 21, we threw in some fractions. And I know I say the word fractions, and that may not be everyone's favorite F word, but fractions scare people, and that's okay. But we do use them a lot in real life, so we need to be familiar with fractions. So we've got 16 plus 2 times 7 over 20 minus 5. Here's what you do. You do everything in the numerator, you do everything in the denominator, and then that fraction bar represents division. So we finish by dividing. Sometimes students want to write it from left to right as one big problem. 16 plus 2 times 7 divided by 20 minus 5. You can do that, but you have to put the numerator, 16 plus 2 times 7, in parentheses, and 20 minus 5 in parentheses. So I suggest instead just leaving it as a fraction follow the order of operations. Like in the top or numerator, 2 times 7 is 14. So I'm going to write this as 16 plus 14. And in the same step, I'm going to do 20 minus 5, which is going to get us 15. 16 plus 14 I did next, which is 30. I've got 30 divided by 15, or 30 over 15. Remember, a fraction bar just represents division. So again, fractions scare people. Division sounds a little easier. We just do 30 divided by 15 to get 2. Number 22, I mixed in some exponents here with the fractions. So in this problem, while I don't have grouping symbols, unless you would choose to write it from left to right in one line, I'm going to start off with the exponents in number 22. So I've got 3 to the second power, which I know is 3 times 3, or 9. So I've got 4 times 9 over 3 times 2, which is 6. 4 times 9 I'll do next, that's 36. 36 over 6 is 36 divided by 6, which of course is 6. Now again, there's a lot of work here. You might need to pause the video here to copy that down. All right, number 23. So we don't have any fractions here, but we've got exponents. So we're going to start with our exponent, 2 to the third power. I'm going to underline that again, kind of get back to where we were. 2 to the third power, we saw already, that is 8. So I have 48 divided by 8 times 3 plus 5. So I'm going to now work left to right. Since I have multiplication and division, remember I do those left to right. You don't have to do multiplication first. So 48 divided by 8 is going to get us 6. 6 times 3 plus 5. I'm going to do multiplication next. 6 times 3 is 18. 18 plus 5 is going to get us, for our final solution, what do you think it's going to be? Oh, that line is not straight. That's going to bother me. You're going to notice I'm a little bit of a perfectionist. 18 plus 5 is going to get us 23. So not too bad there. And you're going to have a chance to try some of these independently as well in a lot of different forms. So if you're a little worried right now because you're just listening to me and writing down, you will have a chance to try some of these on your own. Number 24. I have 12 plus 9 to the 0 power. Start with that exponent. What is anything to the 0 power? If you're thinking 1, or you said 1 right now, you are correct. So start off by doing 9 to the 0 power. That is 1. So I have 12 plus 1, which of course gets me my final solution of 13. We sometimes give problems like this as multiple choice problems, and it's really tempting to choose. A lot of times one of the answers we'll put will be 21, because we'll have students who will choose, they'll think it's 12 plus 9 instead of 12 plus 1, and they'll choose 21. So be really careful. I think sometimes multiple choice problems can be more challenging than open-ended questions. We also sometimes have students who choose 1 because they're like, oh, anything to the 0 power is 1, but we have 1 plus the 12, which gets us 13. All right, we're almost done with our examples. I know, again, this is a lengthy video. Some will be shorter than others. This just happens to be kind of a longer one, which is why the rest of your assignments are not too long. So number 25. Start off inside the parentheses, inside those brackets. So let's do 2 plus 7 first. That's going to get us 9. Don't drop off the brackets yet, because I still have 9 divided by 9 inside the brackets. 9 divided by 9 is in brackets or grouping symbols, so we'll do that next. Hopefully remember 9 divided by 9 is 1. So we have 3 times 1, or 3 brackets 1 minus 3. Next, you want to do 3 times 1, which is going to get us 3. And then 3 minus 3, of course, is going to get us a solution of 0. All right, the last one, number 26, has a star next to it. And a lot of times I'll do that either for a problem that I think is challenging, or one that I think is really important for us. This is a little harder than what you're going to see on quizzes, tests, things like that. But it is a challenging problem. You can feel free to try it on your own. A lot of times I do have students try it on their own. And I get usually about 2/3 of the class get it wrong. Probably about another quarter who kind of give up on it. And then I have other students who get it correct. So let's try this one. Start off with your parentheses. Hopefully you realize that. We've got to do 8 plus 2, and we'll do the 8 minus 3 all at the same time. Why not? So 8 plus 2 is 10. 8 minus 3 is 5. In my next step, I just replace the parentheses with dots. Because students say, well, parentheses come next. But those parentheses just represent multiplication. They aren't grouping symbols. You're not doing any operations inside the parentheses. So when we say grouping symbols, we mean do the operations, do the work inside the grouping symbols. So what we're going to do is we're going to do 5 times 10 divided by 2 times 5. Now, if there were parentheses around the 5 times 10 and the 2 times 5, we would do all of the multiplication first. For multiplication and division, we work left to right. So I start by doing 5 times 10, which is 50. So I get 50 divided by 2 times 5, and don't you dare do the 2 times 5, because we should be working left to right. 50 divided by 2, of course, is going to get us 25. And then we're going to finally have 25 times 5, which if you saw, I almost gave you the answer. 25 times 5, which is 125. That's a tough one. A lot of times I will have students do 5 times 10 and get 50, 2 times 5 and get 10, and then they take 50 divided by 10 to get a solution of 5. So that's the most common wrong answer I get, and if you worked ahead and you got it, please don't panic. I have tricked even geometry students in the past with this. So it's a tough one, but I still like the question, even though it's a little harder than what you'll see on a test or a quiz or classwork assignment. All right, so I put 4 independent practice problems up here. Pause the video. Please try these 4 independent practice problems. If we were in class, we would do these problems. All right, hopefully you pause the video. So for number 1, we're going to do 30 divided by 5 times 3 work left to right. 30 divided by 5 is 6. 6 times 3 is a solution of 18. Number 2, simplify the top, simplify the bottom, and then divide. So 2 squared is 4. 5 times 4 is 20. 20 divided by 5 is going to get us 4 for our solution. Number 3, I'm going to move this up a little bit. We're going to do inside the brackets 3 by 2 first because that's multiplication and we do that before adding. 3 times 2 is 6. Notice how I do not drop off the brackets since I still have a plus sign or operation inside my brackets. 8 plus 6, of course, is going to get us 14. 3 times 14 is going to get us 42 for our solution. Finally, number 4, we've got 15 minus 7 to the 0 power. Anything to the 0 power is 1. 15 minus 1 is going to get us 14 for our solution. All right, so hopefully you feel pretty good about your practice with order of operations at this point. What we're going to do is we're going to stop the video at this point because your practice from here on out, you're going to have if you look at the agenda, you're going to have a worksheet practice to complete on order of operations, including some exponents. You're also going to have a little practice quiz, which doesn't count as an actual quiz, but I still want you to give it a try based on order of operations. You will, in class, have a graded ticket, classwork grade, based on order of operations. So we'll move ahead to some of the other stuff in these guided notes here, including the reflective thinking later. But at this point, you have enough to be able to do that independent practice. Thanks for listening.